Assalamualaikum warahmatullahi wabarakatuh. We are from Group 13 and today we will have a presentation for subject MKW 4023. In this presentation, we will explain our project for ARC and GARCH. Based on the question that asked us to find a set of financial time series data, we decided to use Nestle Malaysia Berhad. The data taken from the Yahoo Finance within 4 years, starting from 24 January 2019 until 24 January 2023. But before we start to analyze the data by using GARCH and GARCH and decided the best model for our data, there are a few steps for us to follow. The first step is to create time series data. Second step is to create data stock of return. Third step is to plot the graph of SCF for test of artifact, and for the next step is to estimate universe GARCH, and the last step is to do GARCH diagnostic. So let's begin with step 1. For step 1, by using S plus and the function of S plus in Phi-metric, we can create time series data which we need to declare the data with the name of the file, and the series of data while post we declare the file name and the day after taking the data before we run the program. And here is the output that we get for the real data of Nestle. Next, for step 2, we create data of stock return. We declare return equal to get return before we plotting. And here is the output for returns data of Nestle. For step 3, we plot the graph of SCF. This is input. We use S plus function to look at the autocorrelation of the plot return and its square return. As we can see, this is the output. From the first plot of the series return, we notice that it did not choose autocorrelation, while the second plot of square return exhibits significant autocorrelation, at least up to lag 5. Since the square return measure the second order movement of the original time series, this result indicates that the variance of return conditional on the past history may change over time. Similarly, for the time series of stock return data, where it may exhibit time conditionally. Next, we proceed the GARCH and GARCH model. For step 4, there is no GARCH effect in the residue, then the GARCH model is unnecessary from the output. It shows that we use LM test to test GARCH effect. We can observe the null hypothesis is no GARCH effect, and the p-value is 0.000. Since the p-value is 0, which is smaller than the conventional level, so we reject the null hypothesis and there is no GARCH effect. First, we have the GARCH effect, and we can proceed to the GARCH model. For step 5, we need to estimate univariate GARCH. From the output, we can observe that the convergence R is equal to 0.0000102897, which is less than the tolerance, which equal to 0.0001. So we can conclude that convergence is reached. From the GARCH diagnostic, we notice that the t-value for ARCH is 1 and GARCH 1 is greater than 2. Thus, we can conclude that t-value for GARCH 1 is significant. However, we still need to do the autocorrelation test to determine the best model of GARCH. Autocorrelation for standardized residual is the p-value is 0.0000. Since the p-value is 0.0000 is less than 0.05, so we are able to reject the hypothesis that there is no autocorrelation. For the autocorrelation test, for square standardized residual R, square the p-value is 0.000. Is less than 0.05, so we are able to reject the hypothesis that there is no autocorrelation. In conclusion, since there is no autocorrelation and no GARCH effect, we decided to choose GARCH 1. So that is the presentation for our group for project GARCH and GARCH. That's all from us. Thank you.